In a long line of people arranged left to right, the 1013 person from the left is also the 1010 person from the right. How many people are in the line? We have a whole bunch of people, dot, 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 and then eventually you get to the 1013th person. And then, let's see here. We also, so that's from the left. Okay, so we're coming from the left. Wait, hold on. I think I mixed this up. No, I'm right. Just second guessing myself. And then from the other direction, you are coming from the right. And eventually you get to... Oh, also, okay, so the same person is the 110th person. Okay, I got it. So let's see. They want to know how many total. All right, well, that shouldn't be a problem. From the here to here, that's 1013. Correct? And then from here to here, that's 1010. So the total would be 1013 plus 1010, but because we counted this guy twice, we have to subtract it once. So this all comes out to 2022. So that would be answer choice B. What is 10 factorial minus 7 factorial times 6 factorial? Let's factor out a 7 factorial, and when we do, we get 10 times 9 times 8, and then that would be minus 6 factorial. And I think at this point, well, I'll just do it manually. This is 720, and that's 720. Oh, okay, well, I guess that's 0 then. So it all boils down to 0. So A is, let's see, what's the answer? B. For how many integer values of x is the absolute value of 2x less than 7 pi? So the absolute value of 2x is less than or equal to 7 pi. So 7 pi is what, approximately 21.98. Okay, so they're concentrating on integers, right? So if I drop the absolute value, the inequality becomes 2x is greater than minus 21.98 and less than positive 21.98. So I have to divide through by 2, and I get like minus 10.99 approximately. 10.99. And then you're just looking for integers in that range. So it would be minus 10, minus 9, minus 8, so on, all the way till 0. And then on the other side, you'd have 1, 2, all the way till 8, 9, and 10. And when you add up all these guys, there's 21 of those integers, and therefore the answer is this E. Balls numbered 1, 2, 3, dot, dot, dot are deposited in 5 bins labeled A through E using the following procedure. Ball 1 is deposited in bin A, balls 2 and 3 in bin B, the next 3 balls in bin C, next 4 in bin D, and so on, cycling back to bin A after balls are deposited in bin E. What bin is ball 2024? So let's understand this question. First, let's put the 5 bins, and they're labeled A, B, C, D, E. And let's go through the process here. So first, we are going to put ball number 1 there, 2 and 3 here, 4, 5, and 6 here, 7, 8, 9, and 10 in this bin, and then 11, 12, 13, 14, 15 in that bin, like that, and then so on. And then we go back, there would be another 6 in here, so all the way, balls 16 through 21, 7 in here, so balls 22 until 28, and so on. You guys get the point. So what are they asking for? They want to know which of these 5 bins is the 2024 ball. Okay. All right, well, let's see here. It looks to me that how many numbers are in each box? Well, cumulatively, right? So let me think about this. So I guess you're just adding 1 plus 2 plus 3 plus 4 and then so on, right? 5 up to some number. And that number eventually get up to 2024 in terms of the total numbers there. Yeah. Okay, so you guys remember that formula, n times n plus 1 divided by 2. And in this case, it's 2024. Now, I'm not going to do a quadratic. I'm just going to do n times n plus 1 is equal to 4048. And I'm going to approximate it. So this is sort of like n squared. It just makes it quicker. And then if I take the square root, I'll get approximately 63. So that's not the actual value of n, but it's close to 63. So let's work with that. So if n is 63, that means that this expression would be 63 times 64 divided by 2, which is 2016. So that is sufficiently close to that guy. So that's pretty good. So that makes me think the following, that the number 1 goes into A, the next 2 numbers go into B, the next 3 numbers go into here, the next 4 go into D, the next 5 go into here. But if we were to use n equals 63, that means the next 63 numbers would go into a certain box, right? And that can be easily figured out which box, because every fifth box is E. So if a number is divisible by 5, it would be E. Now 60 is not divisible by 5. The 60th box is E. But then when you continue this process, the 61st box would be A, the 62nd box would be B, and the 63rd box would be C. Okay, that makes sense. But then we still haven't got up to 2024. We only got up to 2016. So that means to get to 2024, we would have to add 64 numbers in D, and one of those numbers would be the 2024. There'd be 64 numbers, and one of them is 2024. So that's kind of like how you would extrapolate this question. So the answer is D. In the following expression, Melanie changed some of the plus signs to minus signs. When the new expression was evaluated, it was negative. What is the least number of plus signs that Melanie could have changed to minus signs? Okay. When you do this whole thing, according to that formula, it would be 99 times 100 over 2. And that is... wait, hold on. Oh, no. This is not consecutive. I got to read the question carefully. It's skipping over. These are odd. Oh, okay. So if it's odd, then you can't use that formula. It's a good thing I looked at it more carefully. I thought it was consecutive numbers. Okay, well, it shouldn't be too hard. If you pair them, 1 plus 99, 3 plus 97, and so on, you will get that every pair is 100. And then how many numbers were there? 1 through 99, every odd number, so there's 50 of them. So there's 25 pairs. Yeah, so let me just put that here. 25 pairs. And each pair is valued at 100, so it'd be 25 times 100 is the total. So 2,500 is the sum of those numbers. Okay, so that's the first part of that question. Now, the second part is we have to somehow make it a negative. We have to, by changing a bunch of signs there. Interesting. Okay, so that means I'm probably gonna, and the key word there is least. So I want to do it in a way that I put the least number of plus signs that Melanie could have changed to minus. So basically what they're saying is the least number of negatives that I need to put. So that means I'm probably going to concentrate on the bigger numbers. I'm going to make those negatives. That way I don't have to put that many. So the smaller numbers will remain positive, and then somewhere along the line there's going to be a whole bunch of negatives. 97 minus 99. So I have to figure out how many of these guys are negative. Okay, I got it. And then this whole expression is negative, so less than 0. Okay, let's work with that. So then how do I do this now? Actually, I'm just reminded of an expression that the sum of the first odd numbers is n squared. Like, for example, let me give an example. All the way up to n is n squared. Let me see if that holds up. I don't think it's n squared. Let me think about what it actually is. I think I wrote this wrong. It would be the sum until 2n minus 1 is n squared. I think that's correct. So in our formula up there, this guy, this original one, the 2n minus 1 would be 99, and therefore 2n would be 100, n would be 50, and therefore the n squared would be 2500. Okay, that checks out, and you can verify that it checks out with any other kind of value. Okay, that's very helpful that actually I remembered that, because I knew there had to be some formula. I actually remembered the sum of the consecutive numbers formula, but this is the consecutive odd numbers. Okay, so applying that formula to this expression, it would basically be n. Well, let's use a different variable here, since I don't want to confuse this n with this m, this letter. So I'll use m. It would be m squared, and then for these guys, and then it would be, you're subtracting a whole bunch of numbers. So you're subtracting, in this case, it's this guy. So it would be 50 squared minus the m squared, because again, you have to subtract this, and that's less than 0. Pretty sure that's correct. So then when you take it out of the brackets, it'll be 2m squared, and if you put this on the other side, it'll be 50 squared, and if you divide through, you'll get m squared is less than 2500 over 2. So that's going to be m is less than 1250 under the square root sign. So m would be less than approximately 35 point something, 0.3. So if that's the case, then that means my 2m is less than 70.6 or 7, something like that. And then 2m plus 1 would be less than 71.7. I got it. So that basically means that the first one would be less than 71, so less than 71.7, so 71. And then dot, dot, dot. So that is how you get this number. And that's very important. And then you have to just count how many numbers there are from there to there. 71 until 99, the odd numbers. And when you do count them, you get 15. So 15 is the answer. So that would be B. The national debt of the United States is on track to reach 5 times 10 to the power of $13 by 2033. How many digits does this number of dollars have when written as a numeral in base 5? The approximation of log 5 to the base 10 as 0.7 is sufficient for this problem. Now, the number of digits of a number n, let's say, in base b can be approximated by the following. You take the log of n to the base b, and in particular, you're taking an integer, the greatest integer that's less than that or equal to it, and then you add 1. So, for example, in our case, that would be 5 times 10 to the power of 13. That's that number. And we have to take the log of that to the base b, and b in this case they're saying is 5. And then we will take the greatest integer, basically that's what that symbol is. It's sort of an incomplete bracket. So for example, if in case you're wondering what it is, like the example would be, so 5.7 is equal to 5. The greatest integer less than or equal to. Okay, so let's do this here. So this to me looks like the log of 5 to the base 5. Using log rules, we can split it up. The log of 10 to the 13 base 5. And this is just 1. And this, using log rules, the 13 can go out front like this. And don't forget that 1. And let's see here. And there's a log rule we can use now. You guys may remember, may not remember. It's that log of a to the base b is 1 over the log of b to the base a. So I'm going to flip this guy. It'll be 13 times the log 1 over the log of 5 to the base 10, and then plus 1. And then continuing, this becomes 2, this guy and this guy. This is 13, and then this we have been given as 0.7. So we have this as approximately 2 plus 18.5, and that is 20.5. So it looks to me like the closest answer would be 20, and that would be B. In the figure below, WXYZ is a rectangle with WX equal to 4 and WZ equal to 8. Point M lies on XY, point A on YZ, and angle WMA is a right angle. Areas of triangle WXM and triangle WAZ are equal. What is the area of triangle WMA? Well, let's do some labeling, and since the diagram is already there, let's just use that diagram. Hopefully I can fit everything in. So that's 8, they're saying. This is 4, and I'm going to need some labels. I'm going to call this A, and then therefore this would be 4 minus A. And then this I'm going to call B right here, and therefore that would be 8 minus B, right? Yeah, 8 minus B. Okay, now where do I go from here? Well, this is an important one. Those two are equal. So that means that 1/2, where's WXM here? WXM, 1/2 B times 4, which is basically the area, is the equivalent of WAZ, 1/2 A times A. Okay, so that means 2B is equal to 4A, and that means B is equal to 2A. Okay, so that means this would be 8 minus 2A, like that. And then if we need anything else, we can kind of put it later on. Okay, that's a relatively decent start. Now, we're going to use Pythagoras because of that right angle. So that basically means that WM, hold on, let me change colors here. I don't want to use red for the whole thing. WM squared plus MA squared is equal to WA squared. Okay, so that means, what does it mean? Well, WM I can actually have in terms of Pythagoras on WXM, so that would basically be the equivalent of 4 squared plus B squared using Pythagoras. And for MA, it would be 8 minus 8 minus B. Yeah, well, I guess I'll substitute it in later. Plus 4 minus A, all squared. And then the last one, WA, that would be 8 squared plus A squared. Okay, so then expanding this all out, and I'm tempted to have you guys do it, but I guess I'll just do it. 16B squared, 64 minus 16B plus B squared plus 16 minus 8A plus A squared plus 64. Oops, gotta put a equals in there. 64 plus A squared. Okay, you guys know this story, right? Collect like terms, blah, blah, blah. Okay, you guys can do that. So when you do, collect like terms and put it all on one side and reduce it to lowest terms, dot, 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 you will end up with this. A squared minus 5A plus 4. And it's your responsibility to do all that. And then this, fortunately, factors a 4, 1, minus, minus. Now, if you look at the graph, or not a graph, sorry, a diagram, a is obviously less than 4. So the only valid option is a equals 1. If a is 1, then that means b is 2, because of b equal to 2a. So we are doing quite well here, and we need to figure out the area of WMA. Where is WMA here? Oh, that's the inner one. Okay, that shouldn't be a problem, right? So I think I can fit it all on one screen. Actually, we can do it quickly, very quickly. Since b is 1, sorry, b is 2. If b is 2, then the area of this guy would be 1/2 base times height, which is 1/2 4 times 2, which is 4. So they put the 4 there. And then the area of this guy, we know a is 1, so that'd be 1/2 times 1 times 8, so that's 4 also. And then this here, that would be 1/2 base times height. The base looks to me like 8 minus b, so that's 6. And then the height would be 4 minus 1, which is 3. So that's 9. And then the full area was just 8 times 4, which is 32. So to get the area of the inner guy, which is this one, it would just be 32 minus 4 minus 4 minus 9. And that, I believe, is 15. So there we go. That would be C. What value of x satisfies the log of x to the base 2 times the log of x to the base 3 all over log of x to the base 2 plus log of x to the base 3 is equal to 2. So let's flip this first. So log of x to the base 2 plus log of x to the base 3 over the log of x to the base 2 times the log of x to the base 3 is equal to 1/2. I just flipped it. And then when you do this individually, this will become 1 over log of x to the base 3 plus 1 over log of x to the base 2. And that will be 1/2. And then I think we just used this earlier in the contest. We used that log rule that the log of a to the base b is 1 over the log of b to the base a. So this will basically be the log of 3 to the base x plus the log of 2 to the base x. And when the bases are the same, you can use a log rule to combine them. It'll be the log of 3 times 2 to the base x is equal to 1/2. So this basically becomes x to the 1/2 is equal to 3 times 2, which is 6. If we square both sides, it'll be x is equal to 36. And that is it. C is the answer. A dartboard is the region B in the coordinate plane consisting of points x, y such that absolute value of x plus absolute value of y is less than or equal to 8. Target T is the region where x squared plus y squared minus 25 all squared is less than or equal to 49. The dart is thrown and lands at a random point in B. The probability that the dart lands in T can be expressed as m over n times pi, where m and n are relatively prime positive integers. What is m plus n? Okay, let's try to understand this question first. So put it on a coordinate plane. So here's x, here's y. Now the first thing I'm going to tackle is this guy right here. That one is a box like this. Not entirely drawn to scale, but you guys get the point. Where this is 8 up here, this is minus 8, this is 8, and this is minus 8. And the region in the middle is this, represents that inequality. So that takes care of that. That's the dartboard. So that is the, I guess the region. Well, let's just put it over here. I've got to explain this. So this is the dartboard. Dartboard. board. And then we have the target. And the target is a different equation, different inequality. It's x squared plus y squared minus 25 all squared is less than or equal to 49. So that basically means that we've got a circle. This is basically a circle here. It's a circle, I guess, of radius 5, I think. Yeah. If you have, like, I'll do it here, x squared plus y squared is equal to 25. That's basically a circle centered at the origin that has a radius of 5. Okay. So what does that mean for us? It means that we have to try to figure out where that is on this, in this graph. All right, so we have to then work with this guy here. If x squared plus y squared minus 25 all squared is less than or equal to 49, if we take the square root of both sides, then that would be 7 and minus 7, and it would be x squared plus y squared minus 25 in the middle, and then put the 25 on either side, and then that would be 32 and 18. Okay, so that basically means that the circle that's x squared plus y squared has got to be between a radius of root 32 and root 18. So I'm going to attempt to draw this. Root 32 is what, approximately? Root 32 and root 18. I think like 5.6 and 4.2. So that means something like this here. It's not going to be perfect, but something like this here. And then this guy right here. Yeah, that's what we're looking at. And then what's in the middle, that is our target, I guess. Or, yeah. Okay, so we have to figure out basically the probability. So the probability, P, would be the area of that shaded region, which would be basically pi r squared minus pi r squared. So the first r would be root 32, because this is root 32 right here, that point. Well, root 32 squared minus this point, which is the root 18. Yeah, pi root 18 squared. And then that's over the total area. The total area is the total area of the box, and that's just going to be, what would it be? Oh, I got to figure out. Oh, I can't. Oh, I got to figure out the side length. Okay, the side length. Oh, that shouldn't be too much of a problem. We know that we can use Pythagoras. So if that's the side length, s squared would be 8 squared plus 8 squared. So s squared looks like 2 times 8 squared. Right? 2 times 8 squared. And that's basically, s squared also represents the area. So 2 times 8 squared. Okay, so that's the answer, but we got to get it to lowest terms. There's 32 pi minus 18 pi, so that's what, 14 pi? And then all over 2 times 64. So in lowest terms, that looks like, to me, 7 pi over 64. Yeah, I think that's lowest terms. So this represents my m over n pi. So that means the m is 7 and the n is 64. And they want m plus n. So m plus n would be 71. And therefore, the answer is B. A list of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, 7, and xyz. X is less than or equal to y is less than or equal to z. The range of the list is 7, and the mean and median are both positive integers. How many ordered triples xyz are possible? Okay, so a lot of casework here, but hopefully it will not be too bad. So we've got 1, 2.2, 3.2, 5.2, 6.2, 7, and then x, y, and z. Now I don't know what order this is in, but I just put it on the screen, and hopefully we'll figure it out. And the range is 7. And what else do we know? Mean and median are integers. Okay, so we're going to have to do some casework here, I think. So let me make a table. So I'm not sure how many cases we have, but let's start with 3. Because there's 3 variables here, and each of these we're going to have to make a decision as to where they go. And then we have x, y, z, that triple that we're going to have to figure out. And then the range, of course, that has to be figured out. And then the mean, a lot of things here. Let's see here. And finally, I guess the median, which is the middle value. And I think that should be it. So let's see what we can get. Okay. So first thing, we want to look at the range. So let's start with z. Let's say if z is my biggest, well, it is. If you look at that inequality, that's actually very important. Z is the biggest. So let's start off with what's the biggest I can make it. I can make it 8, because remember the range from the biggest to the smallest has to be 7, right? The range is 7 right there. So if the range is 7, that would be in this case 8 minus 1, which is 7. So okay, that works. And that means that the 1 is less than the x, which is less than or equal to y, which is less than or equal to 8. So that part has to be established first. And therefore the mean, you'd have to add up all the numbers. When you add up these guys, the total actually is 24.8. And then plus the 8 for the z, and then plus the x plus the y. And what else are they saying? The mean is an integer. Okay, so this is basically 32.8 plus x plus y. That divided by the total number is 9. There's 9 of them. That has to be an integer. Okay, the only way that's an integer is if this numerator is either a 36 or a 45. That means 36 or 45 for this numerator, this guy. Because if it's 36 or 45, it will be divisible by 9. Okay, if it's 36, then that basically means that x plus y is 3.2. If it's 45, that means that x plus y is 12.2. 12.2. Yeah. So therefore, now we have to figure out the median. We got to make sure that the median is an integer also. So we got 3.2. Let's see here. 5.2. 1, 2.2, 3.2, 5.2. Now we got 8 out here. We got a 6.2. Sorry, we have a 7 also. We have a 6.2. Okay, so the only way the median is going to be an integer is if we need to put an integer in there. The only way I think is if you put a 6 there, and then 6.2, whereas these guys are representing the x and the y, this and this. So that means the x and the y were 6 and 6.2, and then that would mean they add up to 12.2. See, it's all casework here. We got to fiddle around with the numbers. So that means this would be 6, 6.2, and 8. Yeah. And that's how we have to do this. We just have to kind of fiddle around. Okay, let's keep going here. The next one is if you take this guy here and you put it all the way to the other extreme. So we look at x and we say that's got to be 0 because they're all integers, right? Let's see here. They're real numbers. Okay, they're not necessarily integers. They're real numbers. Yeah. Okay. That is how we have to approach this. Okay, so now let's see. What is the range now? The range would be, what's the largest? The largest would be 7 minus 0, and that's 7. So that basically means that 0 is less than or equal to y is less than or equal to z is less than or equal to 7. Okay. And then this part, the mean part, again, 24.8 plus y plus z this time. That has to be divisible by 9. So the only way that would be possible if that number is either 27 or 36. Because it can't be 45 because that's too high, because our numbers don't go up that high because of this inequality. So if it is 27, that means that y plus z is equal to 2.2. Correct? And that, if it's, what's the other one, 36, then that means that y plus z is 11.2. Okay, so now we got to figure out the mean. So let's put all these in. We have 0, 1, 2.2. We have a 3.2 in there. Then we got some number that we don't know yet. We have a 5.2 in there somewhere, right? Yeah, we have a 5.2. Then we have a 7 way out here, and we have a 6.2. Okay, so now we got to figure out what is y and z, fiddling around with these numbers here. And I think that we could get an integer if there's a 5, I think. A 5 and a 5 would go here, and then the remaining value to make it equal to 11.2 would be 6.2. So that would work. So that means this would be 0, 5, and 6.2. Okay, and then I think one more case, I believe. So we can immediately cancel out this guy. And I highly doubt there's infinitely many. So we can cross that out. And then we've got the next scenario, which is when the x is between 0 and 1. Now at this point, the range would be, well, let's see here. The range has to be 7, so this time we're making z minus x equal to 7, and therefore that most likely means that z is between 7 and 8, since x is between 0 and 1. Okay. All right. So we can just shift to the median part. X is the smallest this time. And we have the 1, the 2.2, we have the 3.2, then we have this median, And then we have the 5.2, the 6.2, the 7, and then the z. So what can we do here? Well, we got to do the mean, right? The mean is 24.8. So, as before, that 24.8 plus, in this case, we have x plus y plus z, because we don't know anything here. But this actually helps me. I'm going to let it equal 4 for now, and at least that'll help me get something. That'll be 28.8 then, plus x plus y. And in order for this to be divisible by 9, that has to be 36. So that means that x plus y, or sorry, x plus z, sorry about that. X plus z is going to be 7.2. So these two equations, if we add them, we get 2z is 14.2, so z is 7.1, and therefore x would be 0.1. And that fits that. So that means this one is 0.1, 4, and 7.2. So there we go. Painstaking question here, and we got 3 possible solutions, and therefore the answer is C.